Alright, continuing on. Problem number 12. We have f of x equal x cubed minus 3x plus 2. And I already sketched a graph for that. So it says, verify that the function satisfies the hypothesis of the mean value theorem. Two things to satisfy. One, f is continuous. It's continuous everywhere, since it is a polynomial. Polynomials, radicals, right? Rationals where they're defined and trig where they're defined are continuous and differentiable because their graphs are smooth curves. This is differentiable. Again, everywhere, but we're going to choose negative 2 to 2 because we need to satisfy the condition. Automatically, the outcome, once you satisfy those two, and you could just say polynomial if you wish, that's not a problem. Automatically, the conclusion is that then there is a c in the open interval between negative 2 and 2 such that the derivative of c equals f of b minus f of a over b minus a. And that's pretty much it. It's saying the slope must equal, the slope of the secant must equal the slope of the tangent. Well, two things I need. One, I need a derivative. The derivative of this, f prime, is 3x squared minus 3. And f prime of c is pretty much 3c squared minus 3. Now, I need to find another thing. What's the second thing that I need? I need to find the slope of the tangent, the secant. The slope of the secant is simply f of 2. No need to rewrite it. It's right there. So y2 minus y1 over x2. Well, I know what those are. That's a 2 minus negative 2. Otherwise, it's a 0. That's a 4 in the denominator, right? y2 minus y1. If I throw a negative 2 in, what would I get? I'll get 8, a negative 2 in. I'll get 8 plus 2. 10 minus 12 is a negative 2. Let me make sure. A negative 2 in there, that's negative 8. Oh, negative 8. Minus, well, negative 8 plus 6 plus 2. I'm getting that to be a 0. And if I plug in f of 2, that is 8 minus 6 plus 2, that's 10, that's a 4. So that is 4 minus 0. So that's a 1. So basically, when you say, show that f prime of c equal f of 2 minus f of negative 2 divided by 2 minus 2, you're saying show that 3x squared, you know what, let me stick with the colors, easier to follow. Show that 3x squared minus 3 equals the 1. Well, polynomials I know everything about, specifically quadratics. That means 3x squared equals a 4, x squared equals 4/3, x equals plus or minus 2 over radical 3. And if I plug this in my calculator, that is plus or minus 1.15, about 1.2. Both of those are in there. Well, let's see what we did. If I run from negative 2 and I scale this on 1 each, and if I draw a tangent, if I draw a secant line right where those two cross, negative 2, 0, right? And 2, 4. Okay. Well, this is what the problem's saying. It's saying if you go to 1.15, this is 1. 1.15, about right there. And if you draw a tangent about right there, guess what the slope of that tangent? Okay, I'm way off. 1.15 is a lot closer. The slope of that line will match. This is not a rectangle. These are not to scale because the x is stretched out. And if I go to negative 1 point, this is negative 1, negative 1.1, barely to the left of that, and I draw a tangent line, the slope of that would equal a 1. So that's all the match. Number 20 says, show that the equation has exactly one real root. Well, how are we going to do that? Well, this is what I'm planning. This is what I'm thinking. I'm going to show it has one root. And then to show it's exactly one, I'm going to use contradiction. I'm going to assume it has more than one and go from there. So for one real root, I'm really going to go back to your last test material and say, well, let's call this f. Let f equal 2x minus 1 minus the sine of x. If I take f, I gotta find interval. If I find f of 0, 0 minus 1 minus the sine of 0, that's negative 1. That's less than 0. Very good. If I go for f of 1, that is 1 minus the sine of 1. Okay, that is positive. But if you're not sure without a calculator, go for 2. It doesn't really matter. 2, that's 4 minus 1. 3 minus the sine of x. This is definitely positive because there's the smallest this could ever be is negative 1. And since that's a 3, so that's bigger than 0, I'm going to choose 0 to 2. And this is what I'm going to say, you guys. So I'm going to say f is, you know what, let me do that here. I'm going to say f is continuous. Continuous on 0 to 2. Right? That's all I have to say. F is continuous on the interval from 0 to 2. So, lost my chain of thought. F of 0 is negative 1, which is less than 0. And f of 2 is bigger than 0. Then, automatically, out of those two, what do we know? Once you show those, there exists, or there is, a c in the open interval from 0 to 2 such that f of c equals 0. And this is by what? This is by the intermediate value theorem. Since you did exam corrections, you guys already know about this from the last material, last exam material. So here I have shown that there is one real 0 so far, or the way they want to write it, root. Same thing. Now, how do I show that there's exactly one? Only one. I'll assume there is another. I'll say, suppose f attains or has two roots. Two roots at x equal a and x equal b. 1. F is continuous on 0 to 2. 2. F is differentiable on 0 to 2. 3. F of a, if a is a root, isn't that 0? And isn't that f of b? So what do we conclude out of those right here? We conclude that there is a c belonging in the open interval such that, and here I'm going for Rolle's theorem, f prime of c equals 0, right? I satisfied the third case. Well, what's f prime? F prime is 2 minus the cosine of x equals 0, or 2 minus the cosine of c equals 0, but that's not possible. And why is that? Because 2 can never equal a cosine of any value. The biggest cosine could ever be is 1 or negative 1, This is a contradiction. Therefore, f does not have two roots. If you get a contradiction, I can write contradiction better. If there is a contradiction, that means your original assumption is false. The contradiction negates this. Well, I've shown there's one solution and there can be two solutions, so therefore there's only one solution. And your homework is listed right